Okay. Hi, John and Remy. Thank you for joining to the weekly machine learning study jam. And today, I wanted to have a little bit interactive session because we're going to discuss the data, everything related to data, before we learn different algorithms and run these algorithms on our data. Why I wanted to talk about data? Because of course, when we only start to learn machine learning algorithms, we might not know what kind of analysis we want to do, like what are we going to learn, what we are going to analyze or study. But it's a good practice to have some project in mind or some interesting topic that you want to study, because you will have a goal and you will have something to work on at every stage. For example, when we're going to talk about the data, the first thing that you need to do is to identify what is your data. If you don't have any data, you need to create it, right? And if you don't have any idea what you're going to study, then it's difficult to decide what kind of data you want to create. For example, it can be images or text, and based on the type of data, you are going to create data by web scraping, for example, or using prepared data sets. And in the first sessions of the study jams, we discussed about the problem framing. This one, this course on the left panel. It helped to, there is a like practical session or activity in problem framing, which helps to get the idea of the use of machine learning and what kind of problems are suitable to use for machine learning, right? Or it's better to say when machine learning algorithms are suitable for which kind of problems. So I recommend you to look through this framing session or this problem framing here session to get the idea of what kind of problems you can solve. Let me send you the link again in case you lost it. And today, please feel free to share any thoughts. For example, if you even didn't think about any problems, based on our previous sessions, we already had an experience to classify images or extract some features from images. Maybe you already have some sort of ideas of what you can do potentially with machine learning algorithms. And so today I wanted to start with the representation. Hi, Abdullah. This is the small video, short video. Okay.
So what's interesting is that when we work with data in the real world, it doesn't come to us as nicely formatted feature vectors. Instead, it comes to us as database records or protocol buffers or whatever else. We need to take that data from those heterogeneous data sources and create feature vectors from it. Now, the process of extracting features from raw data is called feature engineering. And it's what real life machine learning people spend, I don't know, something like 75% of their time doing. The features are the thing. So let's take a look at how this might happen. If we have a record that is naturally represented as a real value, like number of rooms in a house, we can just copy that over into a feature vector. And that's very natural. But what if we get a string like Main Street, what do we do then? If we see a string value, we can often translate that into a feature vector by using a one-hot encoding. Now, the one-hot encoding has a unique coefficient for each possible string we might see. So, for example, if we have a one-hot encoding for street names, we'll have a unique coefficient for each possible street. And then when we see this street we have, say Main Street, we'll put a 1 in the coefficient for Main Street and a 0 everywhere else. Don't worry, we can represent that compactly. And we'll use that as our feature vector for representing strings. One-hot encodings are extremely handy for this sort of sparse categorical data. Now, what makes a feature a good feature? Well, the first thing is that a feature should occur with a non-zero value at least a handful of times or more in our data set. If a feature occurs with a non-zero value only extremely rarely, or maybe only once, it's probably not a great feature to use and should maybe be filtered out in a pre-processing step. Our features should have a clear and obvious meaning. This allows us to do good sanity checking and debugging to make sure that our features are being processed properly. For example, it's much easier to have a house age in units of years than a house age in seconds since Unix epoch. Much easier to debug and reason about. So features shouldn't take on magic values. So for example, it would be a bad idea if we had a feature whose job it was to tell us how many days a house had been on the market, for us to use a special value of -1 to show that that house had never been on the market. Instead, a better idea would be to have an indicator feature that would take on a Boolean value showing whether our days on the market feature was defined or not. So we could have Boolean true false 1 0 to show is that other feature defined. And this allows the original feature, days on the market, to maintain its natural units of 0 through n. The third thing is that our feature values shouldn't change over time. This goes back to the idea of stationarity in our data. Now, why might a feature value change over time? Well, maybe our features come to us from some upstream model that might change. We'd like to be able to version that and have a very specific sense, or to be able to get values out of that model that really do have well-defined constant semantics. Last thing is that a feature should not have crazy outlier values. So for example, in our California housing data, if we create a synthetic feature like rooms per person, where we take the total rooms and divide it by the total population, we get some reasonable values of between 0 and 3 or 4 rooms per person for most city blocks. But on some city blocks, we've got values as high as 50, which is insane. I mean, where are these people living? Like hotel blocks? So a thing we can do there is maybe cap or transform our features so that we get rid of those crazy outlier values. One other trick to think about is the binning trick. So if we think about, say, the effect of latitude on housing prices in California, there is no sort of linear relationship from north to south that maps directly to housing prices. But within any particular latitude, there often is a pretty strong correlation. And so what we can do is we can take that north to south latitude and bucket it up into a bunch of little bins. These each become Boolean features. We can use a one-hot encoding here. And essentially what we get is a 1 now if you are in the particular bin that maps to, say, San Diego, or a 1 if you're in the particular bin that maps to the South Bay area, and a 0 everywhere else. This allows our model, a cheap way to map some of those non-linearities into our model without doing any special tricks. So let's think about some good habits here. It's incredibly important to know your data. It's not really a good practice to just sort of treat machine learning as a black box, throw it at data without inspecting the data and hope you get good results, because there will be quirks in your data. So things you can do. You can visualize your data using histograms or scatter plots, various rank metrics. You can do various data debugging that ends up consuming a lot of time for model development, looking for duplicate values, missing values, anything that looks like an outlier, anything that looks like a dashboard that you can interact with your data can be incredibly helpful. And finally, we want to monitor our data over time. Just because our data sources were good yesterday does not mean they're going to be good tomorrow. And so anything we can do to add monitoring to the stability of our features over time will increase the robustness of our systems. So it's interesting.
Okay, so what Hadif, what he just told us is some ways we should study our data. And why I think it's important, before you think about the problem, or maybe before you think about what data you will collect, you should always keep in mind the properties of the data. How would you evaluate it? How would you inspect it? So could you please share, if you're comfortable, any ideas of what type of projects you can do and what type of data you can collect or you already have? And if you don't have this information, maybe based on your any experience or prior knowledge, what kind of statistical tests we can do to inspect our data? Does anybody knows? You can just freely unmute yourself or write in the chat. Some of these statistical methods, I think he mentioned in this video. Any ideas? Let's say, for example, we have a simple problem. We have some X values, independent variables, and Y values, which are dependent variables. And these values can be anything from prices to some measurements in physics, in biology. When you obtain these X values, if it's 10 values, then you can just look at it and qualitatively say something about these values. If there are high difference between some values, it says a lot, right? So that means your data is not normally distributed. But if you have 100 variables or 200 variables, now it's a little bit difficult to inspect it qualitatively, right? We need to do some quantitative analysis. And as we discussed in the previous first sessions, it's not always that you need to use machine learning algorithms to get insights. Some questions can be answered by using simple statistical methods, which are always, I think, overlooked. People don't see the importance of just looking at the normal distribution, looking at the mean values, right? So this is the things that we can do with our data. And I wanted to share with you one. So there are many resources, but this is just what I found that briefly describes the things that you can do with your data. This is the dataset tutorial, not tutorial, like the information, what you can do with your data. So in your variable, in your dataset, you will have some input variables. And for example, if you do the supervised learning, you will have the target variables in this case, or the predicted variables, or the labels, depends on what task are you going to perform, and some unused variables. And in looking at the whole data set, you will have a training samples, validation samples, testing samples, and unused samples. So this is what we have discussed already in the previous sessions, right? Now, this is the tasks that are simple and you can do immediately after you get your data. So let's look first at the simple things like the minimum, maximum, mean, standard deviation. This is what you can calculate for your data. And you can calculate these values for the variables or for the group of the of your data set. For example, if in my case, I had the project where I was studying the effect of nuclear size change on the movement of DNA, the movement of chromosomes. And in my case, I had smaller nuclear size and larger nuclear size and some normal nucleus. So I would calculate the minimum, the maximum, mean or standard deviation for each variable data set. For example, for smaller nuclei, for larger nuclei. This will be useful when I have my data classified into several groups, right? But if I have no smaller or larger nuclei, just wild type, we say, or normal nuclei, in this case, I will just calculate the minimum, maximum, or mean and standard deviation for the whole data set. Do you understand it? So this is what we can do to just see the range of our data and how distributed, how normally it is distributed. For example, we can plot this diagram and see, okay, if it's right or left skewed diagram. Based on this, we can do some other statistical analysis. We can do the box plot to see the how it also tells us a little bit about distribution, but also how variable our data set is. And we can see the time series plots depending on your data, depending on your task, and scatter plots here. And immediately we can say, okay, so if I have the scatter plot, there are several ways I can look at this data, try to analyze the data. For example, it can be just simple linear regression model, right? To predict some values outside the given data set. Or we can classify this scatter plot into several groups, right? So depending on your goal of your project. And some data will be unused. This is when we encounter some outliers, or if we have some data with zero value that we can discard, right? We usually tend to discard some data when we have a lot of samples and less zero value samples. But if our data is small, then there is a way to how to say, modify these empty data samples by adding the mean value into this slot. So this is where the calculation of maximum, minimum, knowing your distribution comes in handy. This is where it is useful. And this source also teaches us about some correlations, and this is what I already mentioned, the outliers, how we can work with the outliers. Should we just delete them or augment them or transform them? Okay, I hope it will be useful. Did I share it? Okay, I shared already. Would you like to share your maybe past experience or current pet project or something that you are working on? What type of data you have? It would be interesting. Or what type of project you want to do, so that maybe in next session we can have a clear tutorial on how to get the data, or I can help you to create the data. Would anyone want to share? For example, Abdullah, you are studying in graduate school. Maybe you already have data. How about Remy, John, Dev? I'm not sure if you're in some research area or you have any pet projects with data or any ideas about the data. No ideas. So okay, so today sometimes I notice on Python study jams and machine learning, you're not so talkative, not so engaging, but I would appreciate your participation just to make these study jams useful for you. Because if I don't have the feedback or like what type of data, what type of projects you want to do, then it's difficult to prepare some real world coding tutorials. And if there is no real world coding tutorials, then it will be boring for you, right? So it's a feedback, positive feedback or negative feedback, I would say. And it's not useful for me and for you. So it doesn't help anyone. Okay, so Dev wants to recognize audio speech. Oh, interesting. Yeah, so this is the natural language processing, right? That's very interesting. Maybe a little bit more advanced. We will talk about it maybe later on, but thank you for sharing. Yeah, I think I was also thinking maybe we should try some natural language processing algorithms, but I was not sure if there are like biology, physics students that are not interested in this natural language processing. Okay, interesting. So based on this audio recognition, what do you think your data type would be? And how would you inspect your data? How would you describe your data?
In my case, it would be voice audio, and it's key to text, like what I said in, for example, English. If I said some word in a in audio, it will be linked to a text like that.
Yeah, so you have some audio format, and would you like to convert it to text, or you would provide the text as a
Actually, I attended a seminar in my college, so in that they converted it to a transcript. So
yeah, I see. And what is the goal of your audio recognition? Why are you interested in this? What would you like to study?
Actually, oh, sorry. Can you repeat?
Yeah, I'm interested why you are interested in audio, like speech recognition, just to develop the algorithm for like creating the transcripts from audio files, or you want to generate some speech or anything else?
Actually, here in India, there are so many languages, local languages. So right now, my college is located in a very remote area between mountains. Even network is very poor here. So and here, I think in my roommates, three roommates, they all have different languages. So I want to make a converter, like what they say for directly conversion. Even not Google provide that much.
Oh, that's interesting. Super useful, right? Nice, nice. Okay. And so if you have the transcript of, if you have the natural language processing, then the instructor from this machine learning crash course said that the text can be transformed into like the matrix, right? Using the one hot encoding. And also maybe you have already heard from other courses, you can use the time series forecasting, which predicts the course of the sentences or the words in the sentence. Yeah, so it's very interesting project. And so keeping in mind the data that you have, what you can do with data helps you to pick the right model or to evaluate how good is your data set. Because if your data set is not so good, then just simply running your program won't do much of help, okay? Super interesting project. Anyone else wants to share his or her idea? If not, let's learn a little bit more about the data before we go to the practice.
Let's start off by looking at a linear problem. You recall that a linear problem is something where we can fit a line to separate, say, the spam from the not spam, depending on a couple of input variables. Here we've got two input variables, x1 and x2. These are input features. And we've got a linear model here of w1x1, w2x2, and a bias term. Now this is easy to fit, right? However, what if our model needed to model something more complicated? In particular, what if our data, in fact, looks more like this? In this world, there's really no way for us to fit a simple linear model that's going to get anything more than about 50% accuracy. What can we do? Well, one clever idea is that we could define an additional feature. We're going to call this a synthetic feature or a feature cross. We're going to do it like this. We're going to call it x3. We're going to define x3 as the product of x1 and x2. Now, can I use x3 in my linear model? Yes, indeed, I can. I'm going to go ahead and add a coefficient, w3, for x3. And you'll notice that the product of x1 and x2 is always positive if they're both positive, or if x1 and x2 are both negative. So I get this very nice ability to pull out my blue dots if the product of x1 and x2 is positive. Similarly, we'll always have a negative if either one of these coordinates is negative. So this allows us to learn a nonlinearity within a linear model using a simple synthetic feature that's called a cross product. So the general name of this process of creating synthetic features as products of other features, we call feature crosses, feature cross products. We can think of these as maybe templates of the form sort of A cross B. They can be complex, A cross B cross C cross D. And when A and B are Boolean features, things that we might get from a one-hot encoding, like various strings or bins, the resulting crosses might be quite sparse. That one-hot encoding may have an awful lot of zeros in it. Let's think of some additional examples here of where feature crosses might be useful. So if we're predicting housing prices in California, we might want to say cross latitude or binned latitude with the number of bedrooms. And this would allow us to learn that maybe having 3 bedrooms in San Francisco is a very different thing from having 3 bedrooms in Sacramento. You could also think about a tic-tac-toe predictor. And you might think of the cross products that you would be able to use there by crossing the various coordinates in the tic-tac-toe grid. Because obviously an X or an O in any particular segment of that tic-tac-toe grid by itself isn't very interesting. But to be able to say your left corner, center, right bottom altogether is a very different thing. So why would we want feature crosses? Well, the main thing is that this allows us to incorporate nonlinear learning into a linear learner. Now, linear learners are very interesting to us because they scale very naturally to massive scale data sets. In fact, for many years, linear learners were the only method that we really had that would scale to billions or hundreds of billions sized data sets. Now, we also have deep neural networks that can scale well. So that's another option that we'll look at later on in this class. Finally, there's been some interesting research showing that combining the effects of linear learning through feature cross products and deep networks can be extremely powerful for modeling.
Okay, if you want to learn a little bit more in detail, then I recommend to just go through this session. And otherwise, let's go to the practice. And here is, in this course, we already know about the problem framing. Now I think it's a good time for us to go to the data preparation step. And this collab, I think you're already familiar with this web page. It allows you to run the machine learning analysis directly on this page. You can clone GitHub page, or you can import any other libraries. Please go to this club page and let's start with the running the environment, setting up the environment. And we are in this step, the data preparation. If you want to know the details on the what are the introduction, not the introduction, what are the steps in data preparation, how to construct your data, how to collect your data, not the tutorials, but just the overview, how to split data, transform it, then you need to read this information. And we are going to do the practice only today. Okay, the setup is complete. Now let's move to the first thing is we need to import every library that are useful for this project. And we already know about the NumPy and Pandas. We also know from Python the math library. And for the machine learning algorithms, we use the Tensorflow and Keras, but here is not going to be used. Let's run it. Okay, it's already completed. Now they suggest us to use the Pandas just to see how it, I think, works for our data. We have here the display options using the dot format. We specify we want to see 2 decimal points of the floats, and the maximum rows that we want to see in our table is 15. So we can run this. It's just maybe not so important for the data processing, but some methods you can use to do basic processing steps. Now let's load the data set with Pandas. So we specify first the column names, which are the feature names as a list. And then we provide the path to the CSV file. And we read this CSV file with .readCSV method. We specify the separator, which is the column. And the column names are the feature names that we already listed as a list. There is no header and we have the encoding of Latin. Okay. If we save the car data and use the dot array index, we can use the how to say, shuffling to ensure that we do not unintentionally create some pattern when we list the data. And we print just the number of our data set. So car data is our data set, and here is the length function that helps us to print how long or how big our data set is. And we see here, so the data set is loaded. It's written here, and we have only 205 examples. Not so big, but not that small, actually, data set. For me, I think, because in my case, we usually create data set ourselves, and 205 seems enough to run some training or validation algorithms. Okay, if you don't have any questions about code, let's go next. So then we want to explore the data. We can use some functions which are listed here. They can, this is just the overview, small overview in case you forgot, but there is also ultra quick tutorial on Pandas on the machine learning crash course in the prerequisites that you can take to refresh the memory on this method. And one of these methods to see your data is just to list the small portion of your data set by describing the rows, for example, from 4 to 7. Let's see what is our data set. And we can see, okay, so we have here different car types, Honda, and some other parameters, right? Like this engine size, fuel system, compression ratio, horsepower, and the price. So this is our data. We can see here. There are many more other parameters actually, and we, from just quick overview, we see, okay, we have all the values seems to be correct in terms of their data type, or they are consistent, right? Let's go next. We create the variable label, which is the price, and we also create the variable numeric feature names, and they list the columns which are of our interest. For example, symboling, normalized losses, wheelbase, and other columns. And we also create the categorical feature names, which are the list of some of the columns here. Now, let's run this. And we got the arrow. And what they want us to do is to a little bit modify this code to get rid of this error. And I'll give you maybe about 5 minutes to think about what's wrong here or what you can do, and we will see the solution here, okay? Any ideas? Do you understand what's going on here? What we are doing? So this is the possible solution. And what we have here is we just create the data set, the list, and here we have somehow the set of two, like the nested list. So let's try to edit it. And the categorical feature name seems to be fine. For now, let's just run it. Okay, so we have here other mistakes. Let me see. Oh, okay. We don't need to index our data with the list, right? Because our data is already a table. If we want to get the first row, which are the column names, then instead of using the indexing of the initial table, which is like car data index 0, right? Or colon. Is it called colon? And first, for example, we just can list the list of these column names. So we don't need to have here the car data, right? Okay, we still have some errors. Let's see what are the mistakes. And yeah. I also noticed that maybe we don't know much about the, let's see, make. We see the column names here are different, but maybe because it's not our, we don't still know our data set well, we might not know if this is the reason of our mistakes. So we have here 15. Let's calculate the number of column names here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we have here the error because simply the length of this variable is not equal to 15, right? So what they do is just, let's copy these column names to ensure that we have 15, but it doesn't matter for now what exactly, the column names exactly we are going to use. Now we don't have any mistakes. So the problem with this code, if I summarize, was that instead of, so first of all, we should be aware of the original data type, right? And we know that original data type is a table or a nested list, right? Or matrix. And if I index this list, and they were like nested list from the original matrix, then it's going to be obviously an error because this is not how we extract the first line, right? And the second thing is we need to be aware that, okay, so maybe we don't know, but there must be 15 column names. So from here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. It might be larger than 15 columns, but somehow for the task, we need 15 column names, and otherwise we got the error. Yeah, so just 2 mistakes from this code. Let's go further. Now, why I ran this code before is that before we can see our created variables, we need to first edit the code to get it done. Otherwise, we have everything else ruined, right? Now, if I run this code again, I should not have any problems. Yeah. So here we have, here we use the indexing. So we specify the column names that we are interested in, that we created here. And this is our index, so-called indexes of the car data. Now we have here the table, which has 15 columns and corresponding values. Everything is good. Let's see the categorical features name now. This is the categorical features name. So what's the difference between this and this table? Why we created 2 different tables? Why do you think we did it? Actually, we didn't create it yet. We just can access these particular values using the created variables categorical feature names and numeric feature names. Do you know? I think it's the first feature that comes to your mind when you look at this table. Because as the name suggests, this is the numeric values, right? Yes, Abdullah, that's right. This is just numerical values, and this is the strings, right? Okay, let's go further. Now we have here the for loop that iterates over the numeric feature names plus the label. So the label is the price, right? And it takes the feature name and it converts the feature name to numeric value. Yeah. So let's see. And then if we have some zero values, which means there are no values at all, then we fill it with the method fill NA, like not applicable, right? Let's see what we get in the end. Maybe we don't, we can actually print our data, right? We can see car data, and so we go categorical, not categorical. Let's see numeric, or just car data. Let's see what. It's difficult a little bit to compare because we don't know where the missing values were, and let's see what's the numeric feature names. This. I see. Okay. We use indexing, not the. Okay. Yeah, from here also we don't see any missing values because anything here is just numbers. but there must be some missing values that we already transformed, right? We don't have any mistakes here. Let's go to the defining our model. So I want you to look at the code yourself and maybe get the grasp or understanding what's going on yourself, and then I will discuss it with you. Maybe around 5 minutes or so, or 2 to 3 minutes, depending on how easy it is to you to understand it, this code. Maybe just briefly looking at this code, something is already familiar for you, maybe not. Anything you know from this code? Anything you understand or familiar? Maybe we already did something in general. There are like several blocks of code. Do you understand in general what is the purpose of this code? If it's difficult to understand, it's also fine. Yeah. Okay. So yes, Abdullah, we need to first define our X and Y variables, right? Or independent and dependent variables, or the variable that we have and we want to predict, for example, or get the relationship. So we have here the batch size 16, and we print our numeric features name and define that our X is going to be the car data numeric feature names, which we already printed before. And our Y values are the price, right? So we can get the idea that the purpose of this project is to analyze how the price is connected to the features. For example, using some features, we can predict what would be the price for a car, right? Or maybe vice versa, why the price, how the price reflects some specific features of cars. And then we define our training, validation or evaluation, and prediction data, right? So here we have the TensorFlow estimator inputs, and we have the Panda input function that, or method that creates the similar. So we have the X values, the Y values, we have the batch size, which is the 16, number of epochs is none, and shuffle is true. And the same for evaluation prediction data sets. And then we have here the list, which is model feature columns. and we take the feature, the column with the feature name, and we save it as a list here. And if we print it, we should get the list of this model feature columns, just a column from the feature list. And then we define our model here. And when I was looking at this code, before, you know that we need to modify this model so that we get the lowest evaluation loss, right? So what I noticed here is that, okay, we have here some DNN, deep neural network regressor, some model here defined, and then we have the feature columns, which we define here, right? And hidden unit 64 and optimizer, gradient descent optimizer with the learning rate of 0.01. So this is the definition of our model, right? And when we train, we use the train method. We can get the score of our training model, right? Let's run this code. So I think looking at this code, we can see here, okay, so maybe this is like the standard thing. There's nothing maybe to modify here. What we are interested here is this this model definition. And we have here some mistakes maybe. So as was written in above, we got none loss during training. This is what we need to avoid. And it's difficult to say how should we modify our model ourselves, because we have no such good experience or knowledge about the different type of models. And what I have, what I want to suggest is, first of all, look at the TensorFlow website with the documentation about the models. For example, you can read about a little bit more about the DNN regressor. And actually, I will say in advance, the problem is with the optimizer here, at least. So they suggest we need to change the optimizer, and we use the gradient descent first, but they suggest to use the ADA grad something. And I found a nice resource for you to, so first of all, check out the TensorFlow, and you can also check, just Google search, what are the differences between these different optimizers. This is the one of the resources that can potentially help you to understand. And let's see. So what they suggest us is to change the optimizer. So instead of the gradient descent, they have here other grad optimizer, and other things stay the same. Let's run this code and see if we encounter the mistake. Okay, our model is learning, right? Here we see the information. While we are waiting, and it's already 6 o'clock, I think I would suggest, so although I might read something about the gradient descent and maybe about this one that we are running right now, I might not still understand why we chose this optimizer, right? And the good thing is that in the TensorFlow, which I just closed, there is a list of different optimizers here. And maybe, okay, here. And you can look at that there are like 10 maybe or so optimizers. And I would be interested myself to try and read the description of this optimizer and run it on this analysis to see what would be the outcome. Maybe we got another mistakes, errors. Maybe we have even better outcome of our training. So this is what I encourage you to experiment on your own. So we have here the scores, the prediction mean, the loss, the label mean. Okay. And what we need to do next is to visualize our model's prediction and add some normalization and create another best model. So this is what we can continue next session. So what we did so far is we look at our data, we inspected using Pandas methods, we created the model. We knew that we need to pay attention to the optimizers and maybe experiment with optimizers, a little bit study optimizers to see what are going to be other outcomes, or maybe we can't use other optimizers in this case, in this type of problem. So this is what you can do next. And in the next session, we're going to go through the code further. Okay. If you have any questions, you can ask right now. And otherwise, this is the end of the stat jam. Or you can share your, maybe you have now the ideas about the project you want to do so that we can create the tutorial, how to scrape data, how to find data. Because I'm interested in how to help you to get the data, how to run your code so you get your project done. Okay, no ideas, that's fine.